Friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. Right. 1 second. I just want to say a very big hi to all of my brothers and sisters who are on the online. Right. 1 second. In the meantime, I hope this will get start. Right. Okay. I just want to yeah, 1 second. Hope it has got started. Right. If you are in online, please say a hi so that I will understand. Right? Right, brothers? Yeah, 1 second. Yeah. Okay, the today's session is all about limit state of torsion. In your previous class, if you had seen, I completed the concept of limit state of shear and problems I need to work out. First of all, I will work out I will complete the problems of limit state of shear. Then I will teach the concepts of limit state of torsion and its problems. This is how it will go. Hi Vasan Sai, how are you? Hope you are fine and everything is working well, right? Yes. Okay, let me have a quick introduction. Okay, right. So before I start the session, I just want to say a very big hi to all of my brothers and sisters who are on the online. And I just want to convey you one more thing. There is so much of free content is already happening in this Unacademy learning app. You please install this Unacademy learning app directly in App Store or in Play Store of your mobile phone. Play Store. When you install this one, so much of free content is already there. And you after you install that one, you if you type this one, if you type this, then definitely you are able to follow me in Unacademy learning app. And some people will also say like, sir, is there any paid courses are already happening in an academy learning app? Yes, there are paid courses are already there. After you install this Unacademy learning app, now set your goal or target. Set your goal or target here as GATE and ESE or the concerned competitive examination what you want to crack. So for that concerned competitive examination, if you press that one and if you go to the main menu, there is a thing called plus codes. Plus codes. Now in plus codes, you go to get subscription. When you had gone to get subscription, use this code BT10, then definitely directly 10% discount will come to you on all the courses that you had purchased in an academy plus platform. Right. Some people will say, sir, why I require this one? There is no need to go to Bombay, Delhi, or Kolkata, brother. All the things, the topmost faculty of India are right now available at your doorstep through an academy. Right. So the doors and windows of an academy will be open when you are able to use this code directly BT10. Right. Some people will say, sir, this is my first lecture, so please introduce yourself first. I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My background of education is completely into structural engineering, brothers. So here also in an academy, I teach all the structural engineering subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. And some people will also ask us, like, sir, what is the specialty of this university from where you had graduated? This university produced six Nobel Prize winners. You can understand producing six Nobel Prize winners from a university is not a joke. You can understand the depth of the research potentiality involved in that university. One thing, and this university ranking is always far better than IITs and IIC Bangalore. If you had taken the ranking globally, in always the ranking of this university stood less than 100 globally. Globally in the sense world ranking, right? From the past 100 years, if you take its ranking is always less than 100, right? Some people will I just want to convey coming to my previous work experience other than teaching. Previously, I worked as research scientist or research engineer in University of South Carolina. This is in USA. For a funded project, I worked as team lead come research engineer there. And in addition to this one, previously I worked as head of the Department of Civil Engineering for an engineering college, STEN in Andhra Pradesh, which is in India. That means both I have local experience and global experience also. Being a structural engineer, even till today also, I am working as an independent structural design consultant. I personally give structural drawings to my clients and material testing reports to my clients, in addition to teaching also. Coming to the teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. This is my brief background, brother. Right. Some people will ask us, like, sir, you asked us to install this Unacademy learning app, na? And you asked us to follow you, and you asked us to take the subscription also. How to follow you, sir? First of all, you install this Unacademy learning app directly in the from the Play Store. After you install this Unacademy learning app, you are able to see a screen which is on the right hand side in this way. In the screen, they said here in the main drop down menu here, go to free classes. When you go to free classes here, and after you go to free classes, in the search button you type my name, Venkata Tilak Uppalapati. When you type this name Venkatadela Kuppalapatti, my profile is visible to you. You just follow me. When you follow me, there are three advantages are there, brother. Already the free content which I had done in an Academy Learning app, you are able to access that one. The upcoming free videos of mine in an Academy Learning app, you are able to access that one. And at the end of each and every lecture, we provide PDF notes for that particular topic. You are able to access that free PDF for that particular topic also for free of cost. These are the three advantages when you are able to follow me. So don't think like we teach all this stuff for free of cost. No, at max 20 to 30% we will teach for free of cost here. For the remaining content, you need to take the purchased course or paid course, right? And some people will also ask us, sir, okay, fine, okay, you asked us you asked us even to purchase the subscription also, like for the paid course. How to purchase the paid course? So how to purchase the paid courses? In the main menu, go to plus courses. In the main menu, after you go to the plus courses here, I can say directly, like, after you go to plus courses, there is a terminology called as get subscription. If you are going to the if you are pressing this if you are pressing this tab get subscription, then I can say it will show the payment terms and conditions and the payment. So by the time you are paying the payment, you need to use the code VT10. Use code VT10 to get 10 percentage discount on all the courses in Unacademy Plus. After that one, whether you can take a installment payment or at a time one single time payment, so you do payment, I can say. This is how it will work, right? Right. And some people will also ask us, sir, is there any other way to follow you? This is the link. If you press this link, in this way also you are able to follow me. This is the link which is clearly here. Right. Some people will say, like, sir, what are the advantages when we had taken the paid course or get subscription? The first and foremost advantage is instant doubt resolution. In addition to daily live classes to 100% extent for the complete syllabus, instant doubt resolution is required to crack any sort of competitive examination. So you can chat directly with the educator, and the educator will resolve all your doubts. That is the first and foremost advantage. Second advantage is, in order to crack any competitive examination, support of test series is required. Test series support. So here also in an academy, we are providing the test series support in terms of live quizzes, in terms of live tests, maybe I can say mock tests, grand tests, daily wise tests, subject wise tests. So all these different tests together will make you understand at what level you people are performing when compared to India, when compared to topmost students of an academy, and you can evaluate your performance. After you evaluate your performance, if you want to improve your performance, definitely you can listen to more number of lectures in that particular topic, and you can work out more number of problems in that particular topic. Definitely it will improve your performance. So like that you can improve your performance and you can evaluate your performance also, right? And I can say like the third one is the courses of Unacademy are completely structured courses. Okay, Sanjeev Kumar, wait for 1 or 2 minutes. I will complete, please. And the courses of Unacademy are completely structured courses, right? There is no need to plan yourself. You need to. I mean, we will provide each and every plan. So if you stick to that plan, definitely we are pretty much sure like you are able to crack any sort of competitive examination with very good rank. And coming to the fourth advantage is, let us suppose on one day Sanjeev Kumar is not able to attend the class. In such case, he will be provided with the same class in the form of recorded version to watch through comfort of any of the device, like maybe a mobile phone, or maybe I can say tab, or maybe PC, depending on his or her comfort. He will be provided access for a number of times, right? And coming to this classes, the classes will be taught separately in English separately and also in Hindi separately. I just want to convey, for in GATE and ESE till now we started 8 courses. Out of the 8 courses, when you had taken subscription, you will be given access to all the courses access, so there won't be any problem also. And coming to the financial terms, for 12 months course, the cost is 27,225 after 10% discount. For 24 months course, the cost after 10% discount is 39,600. So these are the costs you can pay after. For to get 10% discount, you need to use this code VT10, brother, right? So I just want to convey, every day my class is happening by 11 a.m. So in this one, you can follow my classes, especially in Let's Crack Gate and ESC Civil YouTube, YouTube channel, right? So let us directly move to the questions, right? Sanjeev Kumar. Yes, dear Sanjeev Kumar, are you able to see this question? So in your previous class, we completed a theory of limit state of shear. Now we are directly moving to the problems. Is that okay, Sanjeev Kumar? Can you see this question, Sanjeev Kumar, brother? Right? Vasan Sai, can you see this question? Right? Okay, let's start this question, brother. A reinforced concrete beam of rectangular cross section of width 230 millimeter. What's 1 second? Of 230 millimeter. Yeah, of 230 millimeters, though I can say the width is 230 millimeter. And effective depth, how you can say that effective depth, brother? The effective depth can be mentioned as small d, which is 400 millimeter, is subjected to maximum factored shear force. The maximum factored shear force is term is termed as VU, which is 120 kilonewton, isn't it or not? Right. The grades of concrete, main steel, and strip steel are, grades of concrete are FCK, we can call it as, which is 20 megapascal Newton per millimeter square, and yield strength of the steel is Fe 415 megapascal, I can say Newton per millimeter square, and yield strength of main steel, Fi of main steel, whereas Fi of shear reinforcement is how much? Yield strength of shear reinforcement is Fe 250. Na? I can write 250 millimeter square. For there are main steel is provided. For the main steel provided, the design shear strength tau c. The tau c is dependent on FCK and percentage of tension, which is 100 AST by BD. If you refer to the code as per table number 19, this value is given. So which is 0.48 Newton per millimeter square. Tau C, which is shear strength of RCC beam, which is 0.48 Newton per millimeter square. That beam is designed for limit state of collapse. The beam is designed for limit state collapse limit state. Okay. What is the spacing of 8 mm diameter two-legged stirrups? So diameter of the shear reinforcement is 8 millimeter, and the number of legs are, n stands for the number of legs, which are equal to 2. right? They are expecting the spacing. Just to talk about the spacing here, first of all, here tau c is given. I need to compare tau v and tau c, then only I can come to a conclusion like how I can provide the spacing. Shall I need to provide the minimum shear reinforcement? Shall I need to provide the design shear reinforcement spacing? Which formula I need to use? That all depends on the comparison of tau v and tau c, isn't it or not? So let us start working out tau v. Is that okay? So how you can work out tau v, which is nothing but nominal or average shear stress. I'm expecting answer from you guys. If you are in online, please work out because the theory is already over. So tau v, how you can work out this tau v? So which is Vu by the shear area. That the shear area is the cross section area B times of D. So Vu is how much it is 120 into 10 cube by B into D 230 into 400. So what will be the answer, brother? So which is 1.304. This is tau v. Well, how you can compare this tau v and tau c, man? What is the relationship between these two? Tau v is greater than tau c, right? So developing nominal shear stress is greater than the shear strength of RCCB, right? That's what because of provision of tension steel. That's what you can understand. Right, 1 second. Yes, let me. I hope if you people are fine with this one, can I use the next slide to work out this problem in the next slide? Is that okay? Can I use the next slide, brother? If you want, you can take the screenshot. I am expecting directly the spacing by using 8 mm diameter of two-legged stirrups. So if you know how to do, I hope you already know how to do from the theory. You can directly use the theory that I teach you in your previous class, right? So can I use the next slide to work out? Is that okay, Sanjeev Kumar? Sanjeev Kumar, Vasant Sai, can I use the next slide? So yes. So coming to this next slide, if you see tau v is more than tau c, the shear strength of RCCB, sorry, tau v, the developing shear, developing nominal shear stress of developing nominal shear stress is more than shear strength of RCCB. In such case, I need to say it is, and I need to design the shear reinforcement not safe in shear, need to design the shear reinforcement, right? So for what shear force I need to design the shear reinforcement? So if I say VUS is the shear force that needs to be resisted by shear reinforcement, shear force that needs to be resisted by shear reinforcement, how you can say that one, my brother? The actual developing shear force is Vu, no doubt. Out of that Vu, some tau c BD is the shear strength of the RCC beam already before providing shear reinforcement. So I can remove that strength. So tau c BD. So for this shear force, I can work out the spacing of 8 mm stirrups to 8 mm diameter two-legged stirrups. So if you see what is VU, VU is 120 kilonewton. So I can write 120 into 10 cube Newton minus tau c. Tau c is 0.48 into B. What is that width? Which is 230 millimeter and depth is 400. So if you do in this way, the value of the VUS is 75840 newtons. We can write that one. Now after you work out this VUS, okay, after you work out this VUS, what the question is, I need to find out the spacing. How you can find out the spacing by using 8 mm diameter two-legged stirrups, vertical stirrups. I hope you can see these are two-legged stirrups and nothing was given vertical or inclined. So you need to mention it as vertical stirrups only. So for vertical stirrups, how you can work out the spacing? So I can say for vertical stirrups, for vertical stirrups, how you can work out the spacing, brother? Do you have any idea? So for vertical stirrups, you can use this formula. VUS is equal to 0.87 FY ASV into D by SV. Using this formula, you are able to work out. And you know VUS. VUS is 75840. 0.87 FY. What is FY here? FY stands for yield strength of this vertical stirrups. The yield strength of the stirrup reinforcement is given as shear reinforcement is given as 250 megapascal. And ASV stands for the cross sectional area of two-legged 8 dia stirrups. So we can say the cross sectional area is 2 into pi by 4 into 8 square into D. Small d stands for effective depth. How you can work out that? How you can say that effective depth? The effective depth is 400, which is directly given in the problem. 400 divided by SV. If you work out this one, definitely you are able to work out this answer. Now you tell me what is the value of SV, brother. The value of SV is 115.32, but directly I cannot come to a conclusion this is the final answer. Okay, this SV should always be less than or equal to this. These are because of vertical steps na. So this SV should be less than or equal to 0.75 times of D. This SV should be less than or equal to 300 millimeter, right? So this is how you people had worked out. And if you see out of these three values, what is the minimum value, we need to consider that. And 0.75 times of D is 300 millimeter. And SV is 115.32. So out of these three values, the lesser value is this 115.32 na. So directly as a conclusion, we can write the spacing of the shear reinforcement that we can keep SV. Final conclusion is 115.32 millimeter. Minimum of this. Let me write here minimum of the above I need to consider. This is how you can work out, right? Yes. So can I move to the previous slide and can I pick the correct option? The correct option is 115 millimeter. So which stands for the option B for Boston, right? Or B for Bombay is the correct option. Is that okay? Right. Yes. So can I move to the next slide, brother? Please excuse me. Can I move to the next slide? Right. Next question. So this is the next question. And you see this next question. So, right here they are saying the same problem, just like that of the same previous problem, no doubt at all. But I hope you the same previous problem. Data is one and same. The VU is this much. The VU is 120 kilonewton, and this breadth is 230 millimeter. Effective depth same. Data is above same thing. But what they are saying in tau c is 0.48. Right. This is how, and yield strength of shear reinforcement is 250 megapascal. Right. This is how they mentioned, and the beam is designed for limit state of collapse. Okay, in addition to this one, what they are mentioning, the beam is subjected to, so the beam cross section, if you take the beam cross section, is subjected to the shear force VU, and it is already subjected to a torsional torque or torsional moment. The value of that torsional factor, torsional moment is 10.9 kilonewton meter, right? So because of this torsion, I just want to say by the time of limit state of torsion, I will just mention this one. Like when a torsion is subject when a cross section is subjected to torsion, the cross section will be designed for an additional shear, and the cross section is designed for additional bending moment. That's how we can say. And coming to the effective shear force for which we need to design the cross section for shear is V. Effective shear force is equal to VU plus I need to write VT, that is the shear force that is coming to picture because of torsion. What is that VU? VU is 120 kilonewton, and VT is the shear force that is coming into picture because of additional shear force that is coming into picture because of torsion, and it is 1.6 times of TU by V. This is the formula that I want to teach at the time of limit state of torsion. This is at the time of limit state of torsion we cover. So as it is a linked statement question, I may thought like I may forget this question if I don't do here. So that's the reason why I'm working out here. So if it is V, which is already 120 kilonewton plus 1.6 times of TU 10.9 by width in terms of millimeters is 0.23 meter. I can write divide by 0.23. So if you work out that one, definitely it is equal to 195.83 kilonewton. 195.83 kilonewton is the effective shear force. Okay. If that is the effective shear force, then the stirrups have to provided the stirrups have should be provided to carry a shear force. What is the shear force that should be resisted by the shear reinforcement that they are expecting? So what they are expecting, shear force that needs to be resisted by shear reinforcement, right? So if you please excuse me, can I use that? Can I use that? Can I work out that in the next slide? Is that okay? What is the shear force that needs to be resisted by the shear reinforcement vertical steps, right? So if VUS is the shear force that needs to be resisted by shear reinforcement, what is that answer, brother? The answer is VUS is equal to, I can say, effective shear force I need to consider VE minus tau CBD. So the actual developing total effective shear force minus shear strength of RCCB. The remaining shear force must and should be resisted by the remaining shear force must and should be resisted by shear reinforcement L. So which is VE. VE is how much? 195.83 kilonewton. Maybe I can say, or you can write into 10 cube Newton. We can write in this way. Minus tau C. Tau C, it is 0.48 into B. What is the width of the beam? It is 230 millimeter. And D, effective depth is 400 millimeter. This is also in Newtons. If you work out this, you will end up with 151,667 Newton. So in such case, it is 151.667 kilonewton. So this is the answer that they are expecting. The shear force that needs to be resisted by shear reinforcement alone, right? Yes. Can you see this question, brother? The answer is 151 point something. So you can pick this option called as C. We completed two problems, right? Sanjeev Kumar, hello sir, how are you? I am fine, Sanjeev brother. Hope you are also fine, right, Sanjeev? Yeah, yeah. Right. So quickly we are working out the problems. So I already completed a theory. Take it as a challenge, not a challenge. Take it as a thing like so what you learned from your previous class. The same thing we are applying to solve the problems. So I can recommend you guys. If I had given a problem, please take it as a challenge and work out those problems. Of course, to support you at each and every level, I will also do in the meantime in a stepwise manner, but there is no need for you to do all these steps directly. You can mention the answer with the help of simple calculations directly, that is given directly from your calculator, right? There is no need to write everything on the board now for you guys. So you do that, but in the meantime I will write everything slowly so that everybody can understand this, right, Sanjeev brother? Yes. So can you see this next question, Sanjeev brother? Right. So can you see this question? Vasant Sai, Sanjeev Kumar, can you see this question? An RC beam, a reinforced concrete beam of width Same data is same. 230 millimeter effective depth is right now the effective depth has got changed. Okay, the B is 230 millimeter effective depth. Maybe let me change the color better. Yeah, the effective depth, which is small d, which is 450 millimeter, is subjected to a factored shear force, which is VU, which is 50 kilonewton. Right? M20 grade of concrete is used there, so they are saying FCK. Sir, every day my daily timings of my YouTube class is every day by 11 a.m. Every day by 11 a.m. My class is happening, brother Sanjeev Kumar. Every day by 11 a.m. My class will be there, except on Sunday. My class will be there, right? So if you take FCK, what is that grade of concrete? They are saying the grade of concrete is M20. So I can say FCK is 20 megapascal, 20 Newton per millimeter square. Maximum allowable shear stress is 2.8. So what is that they are saying? Maximum allowable shear stress. The maximum allowable shear stress is considered as tau C max, maximum shear strength of concrete, which is maximum allowable shear stress is 2.8 megapascal. Right. The shear strength of the beam. What is the shear strength of the beam? The shear strength of the beam. The shear strength of the beam is given by the terminology tau c. Tau c is the shear strength of RCC beam, which is 0.75 megapascal, which we can write it as Newton per millimeter square. For shear reinforcement, 8 millimeter diameter. The diameter of the shear reinforcement is 8 millimeter, and the number of legs N stands for two-legged stirrups. Two-legged stirrups are there. Mild steel stirrups. When they are saying mild steel stirrup, the yield strength of shear reinforcement is directly 250 megapascal. We can write, and they are expecting the spacing of shear reinforcement in the beam. What is the spacing of shear reinforcement? They are expecting SV. That is the question. To work out the spacing, please understand whether you need to provide minimum shear reinforcement or design shear reinforcement. First of all, you need to understand that one. To understand that one, there should be a comparison between tau v and tau c, right? And tau c max also. So can you work out tau v? How you can define this tau v, brother? Tau v, actually the definition is the nominal or average shearing stress developed because of factored shear force. Nominal or average shear stress due to nominal or average shear stress due to nominal average shear stress due to factored shear force. Can you work out? I'm expecting answer from you guys. Sanjeev Kumar, please try on your own. So what is that answer? Nominal or average shear stress due to factored shear force? The answer is VU by BD. Can I write that one? So what is that value of VU? VU answer is 50 kilonewton. So 50 into 10 cube by B into D. B is 230 into D is 450. If I do this one, then definitely I will end up with this tau v as 0.48 Newton per millimeter square. This tau v is less than tau c. Please understand, tau v is less than tau c, and but tau v is more than 50 percentage of tau c. When tau v is more than 0.5 times of tau c, then what is the conclusion? You can say like it is safe in shear. I can write safe in shear. But when tau is more than 50 percentage of shear strength of RCC beam, at least I need to provide some minimum shear reinforcement to take care of secondary stresses. So need to provide minimum shear reinforcement, isn't it or not? Need to provide minimum shear reinforcement, right? So now I need to use the condition for how we can provide the minimum shear reinforcement, using which equation we can use the minimum shear reinforcement spacing. So I need to work out that, right? So if you please excuse me, can I move to the next slide to do how I can provide the minimum shear reinforcement spacing using which equation, right? Sanjeev Kumar, brother, Vasant Sai, right? So I can say, if I want to provide minimum shear reinforcement, what is the equation as prescribed by Code of Practice IS 456-2000, which is ASV by B into SV, which is equal to 0.4 by 0.87 F5. From this equation, this is the equation for minimum shear reinforcement. Minimum shear reinforcement spacing. This is the equation for minimum shear reinforcement spacing, right? Exactly. So what is this ASV, brother? The ASV, I can say, if you see two-legged stirrups of here SV, here what is spacing of shear reinforcement, na? So let me write, this is the minimum shear for minimum shear reinforcement spacing. Let me write in that way. ASP, two-legged stirrups of, so 2 into 5 by 4 into diameter of the stirrup is 8 square divided by B, the width is 230 millimeter into, I can write SV minimum. This is the unknown. In this one, SV minimum is the unknown. That is the one and only unknown, which is equal to zero point 0.4 by 0.87 F5. Yield strength of the shear reinforcement. The yield strength of the shear reinforcement is, it is mild steel. Na? So let me write 250. Is that okay? From this one, I can work out SV minimum. SV minimum for spacing of minimum shear reinforcement. What is that answer? The spacing of minimum shear reinforcement. The answer is 237.67 millimeter, right? But after this one, I need to check this. This cannot be the final answer. I can say this spacing of minimum shear reinforcement should be less than or equal to 0.75 times of effective depth for vertical shear reinforcement. For vertical shear reinforcement, this minimum shear reinforcement should always be less than even 300 millimeter also. If you take 0.75 times of D stands for 450. Na? So in such case, this value should be less than or equal to 337.5, less than or equal to 300. So out of these three values, 1, 2, maybe let me change the color. Out of this three values, 1, 2 and 3, what is the lesser value? Generally I can use this. So let me use out of these three, minimum of these I can write. So what is SV minimum? I can finally come to a conclusion. The SV minimum I can finally come to a conclusion is 237.67 millimeter. This is how you can work out. So if I go to this options, 237 is there. Now what is the nearest option that is there for 237? Option D, 230 millimeter is the nearest one. So I can keep option D for Detroit, D for Delhi is the correct option. Is that okay? Is that okay? Right? Sanjeev Kumar. Right. So can I move to the next slide? Yes, Sanjeev Kumar. Right? The option is D for Detroit is the correct option. Moving to the next question. I hope you are able to see this question. In the above problem, the data is one and same, just like your previous problem. In the above problem, if factored shear force is changed to 100 kilonewton. So the one and only change is the VU is 100 kilonewton, and tau V is equal to VU by BD. Tau V is equal to VU is 100 kilonewton, 100 into 10 cube Newton by BD. The width is width of the B is, for your previous problem, it is 230 millimeter. Na? And I mean, it's a linked statement question. So that's the reason why how this question was framed. Yeah. And effective depth. I hope you, if you see the effective depth in your previous question is for 450 millimeter. So let me write here 230 millimeter by 450 millimeter Newton per millimeter square. If you do in this way, They are expecting the spacing of 8 millimeter diameter stirrups. So please understand, now the shear force has got increased. When the shear force has got increased, tau will get increased. Then there is a chance like I need to design the shear reinforcement, right? So can I work out that? Yes. So what is this tau v value? The tau v value is 0.966 megapascal Newton per millimeter square. This is greater than tau c. Tau v is greater than tau c. And if you come down, VUS, and if you come down VUS, how you can write VUS? VUS is equal to VU minus tau c into BD. What is that value of VU? It is 100 kilonewton minus tau c. What is that value of tau c that is given in your previous problem? So if you see the previous problem, the tau c is I think 0.75 it seems. Yes, the tau c, the shear strength of RCC beam, which is tau c is 0.75 millimeter. So second. Right. So minus 0.75 into Newton per millimeter square into B. Width is how much, brother? 230 millimeter into effective depth is 450 millimeter. So if I write here 100 into 10 cube, this is in Newton, this is also in Newton. It will end up with the answer of 22375 Newton. The answer is 22.375 kilonewton. This is how we can work out. After we work out the VUS, how what is this answer of this VUS? It is the shear force to be resisted by shear force to be resisted by shear force to be resisted by shear reinforcement. Shear force to be resisted by shear reinforcement. Now the question is, okay, now I need to work out that one, right? This tau v is greater than tau c, so I need to design the shear reinforcement, right? So let me write that one. Need to provide design shear reinforcement, right? Now how we can provide this spacing of this design shear reinforcement by using this equation VUS is equal to 0.87 Fy ASV into D by SV. From this one, if I am able to work out that spacing of the shear reinforcement, the problem is over. Now coming to this VUS, the answer is 22,375 is equal to 0.87 Fy. The yield strength of the stirrup steel is 250. And ASV, how we can say as ASV? ASV is equal to 2 into ASV, area of shear reinforcement, and it is two-legged stirrups of 8 millimeter diameter, spacing of 8 dia, mild steel stirrups of two-legged stirrups. So two-legged spacing of two-legged 8 diameter mild steel strip. 2 into pi by 4 into d square is 8 square into effective depth. What is the effective depth? Effective depth is 450 divided by ESV. ESV stands for spacing of spacing of the shear reinforcement. So from this one you can understand like SV is equal to 439.75 millimeter. This is the spacing of the shear reinforcement. But shall I need to provide this directly? Let me check. I always the spacing of the shear reinforcement that we are designing should be less than minimum shear reinforcement value should be less than 0.75 times of t should be less than 300 and all this stuff, right? So let me come to that conclusion and let me finalize this one. So how to finalize that one? SV, the spacing of the shear reinforcement, it is minimum of, I can say, What is the value that you got, man? The value that we got is 439.75 millimeter. And next one is should be minimum of 300 millimeter. And the next value is 0.75 times of D, which is this D is 450, na? So 0.75 into 450, it is 337.5 millimeter. And I can say SV. In addition to this one, this is the design shear reinforcement spacing of design shear reinforcement. Spacing of design shear reinforcement should always be less than or equal to minimum shear reinforcement spacing, SV minimum. So coming to this minimum shear reinforcement, in your previous what you call problem, we had already worked out the spacing of minimum shear reinforcement. What is the spacing of minimum shear reinforcement for the same problem that we worked out in that we worked out in previous problem? What is that answer, brother? It is 237, I think. Let me show you here. This is using for minimum shear reinforcement. This is the spacing. What is the spacing for that minimum shear reinforcement? We got 237.67. So let me use that. So this value should be less than or equal to even minimum shear reinforcement spacing, which is 237.67. If you forgot this clause, you may end up with wrong answer. Always the spacing that you are providing, the design shear reinforcement spacing that you are providing should be less than or equal to minimum shear reinforcement spacing, should be less than or equal to 300 millimeter, should be less than or equal to 0.75 times of D when it is vertical shear reinforcement, right? Yes. So please be aware of this one. If you miss this one, you will end up with wrong answer. What is the minimum of these four? The minimum of this four is 237.67 millimeter. So what is the option that I can pick here? 237. No? So here, yeah, the option I can say is 230 millimeter. Generally, after you work out, you may end up with the answer of B, right? But if you pick the answer of B, that it is a wrong answer, right? So please be aware of that one and take a necessary or perfect answer, right? Is that okay, Sanjeev Kumar? Is that okay, Sanjeev Kumar, brother? Vasant Sai, is that okay? Can I move to the next slide? I mean, next question. Is that okay? You please excuse me. I will move to the next question. Right? Moving to the next question. Right. The question is same in the same above problem. The problem data is just like that of the same problem, right? No doubt at all. But the only change is the shear force value has changed to 150 kilonewton. The VU value, VU is 150 kilonewton. At support, I can say they are saying at support, two bars of 16 diameter of Fe4 and 5 are bent up. Some bars are getting as bent up bars also. Two bars are bent up. So please understand. It's a two bars of 16 millimeter diameter. Two bars of 16 millimeter diameter of Fe4 and 5 steel are bent up. Then in such case, what they are expecting, the spacing of 8 millimeter diameter mild steel slabs. So first of all, you try to work out the shear force that needs to be resisted by shear reinforcement first. So first of all, you need to work out tau v. Step one. What is that step one? I need to work out tau v, which is equal to Vu by Ud. That Vu is 150 into 10 cube Newton divided by B into D. What is the width and depth? The width and depth in the above problem, the previous problem, the width B is 230 millimeter and effective depth D is 450 millimeter. It was already mentioned in the problem. So I can say 230 into 450. millimeter square. If you do this one, the answer for this one is 1.45. And tau c as given in the previous problem, the value of this tau c is 0.75 Newton per millimeter square, and tau c max. Tau c max it was given in the problem is I think it is 2.8 is the tau c max that was given in the problem. 2.8 Newton per millimeter square is the tau c max that was given in the previous problem, same data. So I worked out tau v. Tau v is the nominal shear stress developed because of factored shear force, or nominal or average shear stress developed due to factored shear force. It is 1.45, I can say 1.45 Newton per millimeter square. This is how we can work. So when tau v is equal to 1.45 Newton per millimeter square, right? Then tau v is greater than tau c. Then when tau v is greater than tau c, you should understand like need to design the shear reinforcement, right? Need to design the shear reinforcement. Will you accept this? When I need to design the shear reinforcement, generally here they generally you can write that VUS. What is VUS stands for? Shear force need to be resisted by shear reinforcement. I can say need to be resisted by shear reinforcement. What is the shear reinforcement that was provided? The shear reinforcement one is because of bent up bars. Bent up bars cannot be used alone. Bent up bars are used in association with 8 mm diameter of mild steel stirrups, right? Shear reinforcement here in this sense, I can say using bent up bars plus vertical stirrups together. What is that answer? Which is VU minus tau C into BD. If you work out that VU into tau C into BD, VU is already 150 into 10 cube Newton minus tau C. Tau C is 0.75 into B into D. What is that B into D? That B is 230 millimeter into D. Effective depth is 450 millimeter. So this will be Newton per millimeter square, and you will get this answer in terms of newtons. If you work out this, finally the answer in terms of kilonewtons will be 72.375 kilonewton. 72.375 kilonewton. Now the question is, what is the spacing of that 8 millimeter diameter mild steel steps? Please understand one thing here, right? If you take this VUS, it is the shear force to be resisted by shear reinforcement. The shear force to be resisted by shear reinforcement is shear force to be resisted by bent up bars plus shear force to be resisted by bent up bars plus shear force to be resisted by vertical stirrups. They are expecting spacing for this shear force to be resisted by these vertical steps. Now I need to work out if it is VUS, I can write this as VUS1 plus this is VUS2. So coming to VUS1, what is the shear force to be resisted by bent up bars or shear strength of bent up bars? Shear strength of bent up bars. What is the rule that I mentioned? Bent up bars. So the shear strength of bent up bars is 0.87 Fy ASV into D. ASV 0.87 Fy ASV into this is in ASV into sine alpha. So which is 0.87 F5 yield strength of the bent up bar. The yield strength of the bent up bars is Fe415 into ASV. ASV stands for uh, cross section area of stirrup reinforcement. The cross section area of stirrup reinforcement. What is that answer, brother? Cross section area of stirrup reinforcement. Not stirrup reinforcement. ASV, area of cross section area of bent up part. What is the cross section area of bent up part? Let me write here. Cross sectional area of bent up parts. What is that answer? Two bars of 16 millimeter diameter has got bent up. So I can say 2 into 5 by 4 into 16 square. And alpha. Alpha is the angle of bent up. So if you take this angle at which the bars has got bent up. So the angle of bent up bars, I forgot to provide. So the angle, hello, hello, hello. Yeah, right. Sorry guys, sorry about that one. I mean, there is a power failure happened at internet service provider, and right now it has got sorted. So please excuse me about that. Right now we are in online again. So if you see, uh, what is VUS1, which is nothing but the shear strength of bent up bars. So how you can work out the shear strength of the bent up bars using this one, where ASP stands for the cross sectional area of bent up bars. If you work out this one, the answer for the for the answer for the shear strength of bent up bars is 102.66 kilonewtons. And one more thing rule I already mentioned in your previous class, brother. The rule is the shear strength of this bent up bars VUS1 should not be more than 50 percentage of shear force to be resisted by the shear reinforcement. Should not be greater than 50%, 0.5 times of VUS. So if you work out this one, the value of VUS you already know, right? What is the value of VUS? The value of that VUS is directly 72.35. I hope if you see the previous slide, it is 72.335. You had already worked out. So I can say from this one VUS, which is 102.66 kilonewton, should not be greater than zero point 0.5 times of 72.375. So in such case, the value of VUS1, the shear strength of the bent up bars at max, even though the by formula it was coming as 102.66, from the condition I should limit that value as zero point 0.5 times of 72.375, which is which is 36.1875 kilonewton. 36.1875 kilonewton, right? So if I got this as for 36.1875 kilonewton, now you can understand the VUS1 is 36.1875. Here VUS, which is 72.375. So what is the answer of VUS2? VUS2 is the shear force to be resisted by vertical stirrups. Shear force to be resisted by vertical stirrups. The answer is that VUS2 is definitely equal to 36.1875. From this equation, I can get that VUS2 as this much. Okay. Now the question is, everybody will also ask us, sir, I need to provide this, I need to work out the spacing of vertical stirrups to resist a shear force of 36.1875 kilonewton. How to do that one? I am going to that one only. So can I rub the screen, brothers? Dear Sanjeev Kumar, brother, can I rub the screen? Can I rub the screen? So let me erase all the ink on the slide. Okay, let me erase all the ink on the slide. Right. So here I can say when VUS2 is equal to the shear force to be resisted by vertical straps, which is equal to 0.87 Fy into ASV into D by SV. This SV I need to work out. So the VUS2, which is 36.1875 into 10 cube. Fy, yield strength of this stirrup reinforcement. What is the yield strength of the stirrup reinforcement? The yield strength of stirrup reinforcement is 250 Newton per millimeter square. What is ASV? It is two-legged stirrups of 8 millimeter diameter. 2 into pi by 4 into 2 into pi by 4 into I can directly write 8 square. What is the value of this effective depth D? The effective depth D is 450. From this one you can work out this SV. So what is the value of SV? SV is equal to 271.902 millimeter. SV, spacing of the shear reinforcement is 271.902 millimeter. Now, but after this one I need to, but I cannot directly fix this value of the spacing of the shear reinforcement. How I can fix the spacing of the shear reinforcement? Yes, so I can use this I can use this one here. So the value of SV spacing is minimum of the spacing that we got from design shear reinforcement, which is 271.092, and it should be less than or equal to 300 millimeter, should be less than or equal to 0.75 times of d. What is that 0.75 times of d? 0.75 times of 450, and this value should always be less than even SV minimum. What is the minimum shear reinforcement spacing that we got? The value of the minimum shear reinforcement spacing that we got is 237.67 millimeter. Out of these four, whatever may be the lesser value, I need to finally fix that value as a minimum shear. I need to fix that value as the spacing of the design shear reinforcement. Right. So what is that value out of this one lesser value, brother? So the lesser value is SV is definitely we can come to a conclusion which is directly 237 points. So SV, the spacing of the shear reinforcement at max you can keep as minimum shear reinforcement spacing only, which is 237.67 millimeters. So you need to take this option as the 237.667. You should not consider the option as 271.902 because this is the checks. Based on the checks, what is the final value of SV? SV final. What is the final value of SV? I can make 237 millimeter. Na? So let me go back. Let me go back, and it is 237.5 millimeter. So it is 237.5 millimeter in sense. So the option is the nearest option is C, which is 230 millimeter is the answer. This is how we can work out, brother. Right? Yes. And we completed limit state of shear problems, man. We came down to limit state of torsion, but due to power problem for today, as the power has got off, like there are no fans and lights are going, so please excuse me for today. For only 1 hour, I am stopping. But by tomorrow, I can deal with more hours. Like tomorrow, I can take marathon like 3 hours or 4 hours, and I can complete that one. But unfortunately, for today, what happened is there is a power cut happened. So because of that one, I feel suffocated here. So please excuse me for today. I am just stopping the session. Tomorrow we will take care about this limit state of torsion completely. Okay, right. So before I end up the session, I just want to convey you one thing. If it is a 12 months course, the cost for of the 10 percentage discount in case of subscription or paid course in Unacademy Plus is 27,225, and if it is a 24-month subscription, the cost after 10 percentage discount is 39,600, right? So, and one more thing also I can say, to get this 10 percentage discount every time, by the time while you are purchasing, you are bound to use this code VT10. And you are bound to use this code VT10, directly 10 percentage discount will come on all the courses in an academy plus, right? So, and one more thing, every day my class is happening by 11 a.m. So please be aware of that one. And please come down. I mean, if you are interested of gate to crack gate or ESE or any other competitive examination, you are bound to come. You can come down to this class and you can learn these concepts, right? So this is the end of the session. Before I end the session, I just want to convey you. Please subscribe to this Let's Crack Gate and ESC Civil YouTube channel. Civil YouTube channel. When you subscribe to this channel, the upcoming videos of upcoming videos in this channel will be notified to you. Don't forget to press the bell icon. Please press the bell icon so that the notifications of the lectures will be notified to you in this YouTube channel. And moreover, please raise a thumbs up so that we can do more number of free videos for you, right? So please share these videos to your friends and ask them to watch these videos, share these videos, like these videos, and subscribe to this Let's Crack Gate and ESC Civil YouTube channel, right? And I want to convey one more thing for you guys, for your convenience. I already started a Telegram group of mine. The name of the Telegram group is Unacademy underscore Civil Engineer Tilak. You can come down to this channel. After you come down to this channel, right, you can post your queries. When if you are able to post your queries, I will take care of your queries directly in this Telegram group, and the Telegram group link is given below. This is the link of the Telegram group is given below. You press that link, and here it is an academy underscore civil underscore engineer underscore Tilak. In this one, U is capital, C is capital, please be aware. Engineer, E is capital, T is capital, right? So like that, if you press that one, you will redirect to my Telegram. Okay, right. Thank you. End of the session for today.